name is Paul Emerson, and I'll be giving you my 2 cents. I'm currently taking programming 1 at Fullsail University, and it's 11:30 p.m. and I'm sleepy and tired. I didn't do my homework. I finally got my grade for my first week. I need to just finish these assignments. Let's do the work. Get ready for the rest of the week and start programming 2. And I've got one more video to finish watching.
we should be ready to get started here. I gotta fix some stuff on my end real quick, and then we'll keep going. Alright, so let's go over here, and we start with our hole.
So tired. 3 days to finish all of the assignments, and then I have to start working on my partial.
So we're gonna
Not my partial, my practical.
run that.
And then week 3 is after my programming, which is going to be really difficult.
So what is the best indie game of all time? Also, what qualifies as an indie game? Undertale absolutely cool. I think as far as that one goes, that one 100%. Cuphead indie-ish. Yeah, Minecraft. I think so. For me, I think Minecraft is really like the pinnacle here because like what Minecraft has become is insane. And it definitely started off as like, yeah, an indie game for the majority of its life. Honestly, for the vast majority of Minecraft was done under an indie studio. Also, I think Hollow Knight is mid. Just saying. I think it's a just fine Metroidvania. What's going on with my... The camera is not working. Angry Birds. There's no way in any world that Rovio was an indie company. As much as I enjoyed Angry Birds, I don't think that was the case. Schedule 1. The best indie game of all time is Schedule 1. It's really There's a lot of, yeah, it's like, I was gonna say Valheim. Like I said, Val's Towers and Valheim. I think Valheim is great. Honestly, Repo is great. Repo is incredible for the small team that's working on it. There's a lot to choose from these days, right? Like I said, like I've never played Minecraft in my entire life. I've never opened it up. I own it on like 3 different platforms. I've never played it. But I still think it's probably the best indie game. Equal to 6, and then math operator operation is going to be equal to math. I've never opened it up. I own it on like 3 different every time, right? Which means now, let's see if it makes a difference and what difference it makes. So if it is between 1 and 10, we have an invalid variable, and we're going to say this is not invalid. We're going to set invalid default. If we are looking for a specific thing and we need to know where it is,
okay, it's a little different. I need to watch all of those videos.
Be ready to get started here. I gotta fix it. Operation. I'm putting together the parts of my math operation. I'm gonna say, okay, I'm gonna make an int, right? My computer. So what, if anything, from the previous lecture would you like me to review?
Numerator.
Somebody turn the volume down over there? No, it's gotta be my computer rolling. No. Stuff is just quiet now. I don't trust that. Get a little bit longer. People are typing, and then while I do that, I'll open up Visual Studio Code. Switch statements. It's easy enough. We can talk about both those in the same way. So here is our enumerator. The enumerator denotes something. What that something is could be whatever. Could be colors. Could be math operators. Could be HTTP status codes. Whatever it is, it's just associating something with a number. The number doesn't matter. We don't care about the number. We just need to know that if something comes up, if the something we're looking for comes up, that we can compare it to itself, essentially, right? So, for example, if I'm trying to do a math operation, right? If I'm trying to do a math operation, I'm putting together the parts of my math operation. I'm going to say, okay, I'm going to make an int term1 is equal to 4, int term2 is equal to 6, and then math operator operation is going to be equal to math operator subtract, right? Now subtract has a number associated with it. I don't know what that number is. I don't care what that number is. That number has no meaning to me. It's not important. All I need to know is that if I call a method that says like int do math, and I take in an int term1, an int term2, and a math operator, right? Then I make sure that I do the right thing based on the math operator that was selected, right? So for here, say, okay, if, so we say int result is equal to 0. We say if operator is equal to double equal sign for comparison, not single equal sign. So double equal sign for comparison, math operator add, then I'm going to add term 1 and term 2. Right? As simple as that. But if it's not that, right? If operator is math operator subtract, then I'm going to subtract term 2 from term 1, so on and so forth. Again, there's a number here. I don't know what that number is. That number does not matter to me. All I need to do is be able to say, hey, when I'm doing this math operator, I want to subtract. So I'm going to write out words in English that say I want to subtract. And then down here, when I check what those words are that I wrote, if they were subtract, then I'm going to subtract. If I wrote add, I'm going to add. So it really does not matter what's going on behind the scenes, the stuff that we don't see. What really does matter is the stuff that we do see, because it makes it easier for us to actually make determinations based on human readable stuff. Now, switch statement can go the same way, right? So in here, what we're doing is we would effectively compare operator up against all the possible values of operators, everything that's in our math operation, right? So since we're comparing one thing against multiple things, right, this is a great opportunity to use a switch statement instead. So for here, instead of doing math operator is equal to this, or math operator is equal to this, or math operator is equal to this, etc., 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 we can just do switch, pass in the math operator, and then say, okay, in the case that math operator is equal to math operator add, do this. Otherwise, if it's math operator dot subtract, or math operator not dot subtract, but math operator subtract, do this. so on and so forth. So it's the same thing as me doing if operator is equal to this, if operator is equal to this, except if operator is equal to this, if operator is equal to this, all the way down. We don't require you to do fall through or anything like that, so that other stuff that switches can do, I don't make you do, but I do show it to you in case you run into that issue, because you don't have break statements in the middle of each one of your cases. Are there any other questions on any of this stuff?
So after math operator, you have add, subtract, all in all caps. Does it matter? Does it need to be in all caps?
No, it just depends on how it's written in the enumerator, right? And the pattern for something that cannot change, something that has a value that cannot be changed, is to write the name in all caps, so you have a reminder that it can't be changed. So I can't change, like, once the enumerator is made, I can't change the value of red. It is what it is. It's 0 here, right? I can't. It's never going to change. So I put it in all caps because that's just the pattern that I'm used to.
Okay, thank you. That makes sense.
Yep, no problem. Any other questions? All right. So today we are going to talk about looping and iteration, right? So there's going to be 2 primary types of loops we talk about. Like, there's going to be more than 2 loops, but there are going to be 2 types of loops that we talk about. So let me minimize this. Actually, no, let me move this down here. So the first type of loop that we will talk about is called an indeterminate loop. So like if you use a mobile phone, if you've used a cell phone in your life, you've seen one of 2 indicators. You've seen an indicator that looks like this, progress indicator looks like this, and a progress indicator that looks like this, right? So the progress indicator that is a progress bar, we call this a determinant. This has a known start and end. Goes from 0 to 100. So right now this one is at about like, at like 80, right? So this is determinate. This has a clear start and end. This is an indeterminate. This will spin forever until something happens, right? Until you connect to the internet, until the page loads, whatever it is. We don't know how long it's going to take, but we're going to show you that something is happening until you actually get that thing, right? Any questions about that so far? Okay. Next up, what we are going to do this is do the same thing over and over and over. That's it, right? So at the end of the day, imagine we had an if statement, right? So if thing is true, right? Then do thing, right? But not just do thing, right? Continue doing thing so long as thing is true, right? So if this is true, keep doing this thing. Does that make sense? So at the end of this, what it's going to do is it's going to go right back up here, and it's going to keep doing the whole thing over and over and over until thing is no longer true. So if you're looking at this now, understanding this as it is, one thing is clear, and that is that if thing does not change, this will happen forever, right? So that is what we call an infinite loop. If we are using one thing to determine whether or not we continue doing what we do, then that thing must be something that changes. Does that make sense? All right. So if that thing must change, and the only thing we're doing is the body of this loop, then this thing, the value of whatever this is, must change at some point inside of this loop. Keep that in mind. So let's look at the slide and see what that looks like. If we want to think of this in terms of our reference game too, by the way, think about what happens during your average JRPG battle, your Pokemon battle, right? What happens is each player goes back and forth forever until one of them has no Pokemon with no health, right? So that is literally the logic we will use if we get to the battle part. And that's the kind of thing that we're talking about here. The syntax that makes it repeat itself, Brendan, is just making sure you open the construct with the right word. So if we make a loop, it should continue. At least this particular type of loop. There's going to be another loop that I'll show you as well. So iteration just means we do the same thing over and over and over. Iterate. In programming, that can be described as a few things. The first thing is just doing one thing repetitively. So doing one thing until we're done, right? Keep trying to load the page until the page loads. Keep trying to reconnect to the internet until the internet reconnects. Keep going back and forth between player turns until one player has no more Pokemon with health, right? Those are indefinite iterations, right? Perform an operation, check to see if we got the result we were looking for. If we didn't, do it again. Keep doing that, right? The other thing we're going to do is we're going to do counting. That is doing something for a specific amount of times, right? So for example, if I have a menu, we saw a lot of menus, right? And there are 5 things on that menu. There will only ever be 5 things on that menu. It just says print the menu items 5 times. So 1, 2, 3, 4, 5. Those are our 5 menu items, right? Because printing those menu items is going to be the same every single time. So just do that 5 times. Done. Any question about that? Does that make sense? All right, cool. So to do this, we use what's known as loops. So we're going to talk about 2.5 different loops. Really, in any other language, it would be three completely different loops. But we're going to talk about 2.5 different loops. One of them we are not going to talk about today. One of them we are going to save for Friday, because it works kind of in conjunction with collections. But the 2 loops we're going to talk about today, the first one is going to be while loop.
Today is Friday.
So while loop is what I described before. A while loop is the same thing as an if statement, right? It will just continue so long as the condition is true. So whereas an if statement,
I didn't really watch this video because the media that I'm trying to watch is today. No, I mean I'm trying to watch this today because today, fuck. My work schedule and their schedule is not unified. I'm tired. I need to go back to sleep. I was supposed to watch Monday's video on Monday and Wednesday's video on Wednesday. I watched Monday's video on Tuesday because it didn't get released until the 4th. And I watched Tuesday's video yesterday because for some reason it actually released on time. And the video I'm trying to watch right now, while I have the time to watch it based on the schedule I set for myself, would be, well, I would be doing my assignment right now. But I can't do my assignment because I need to watch the video for the assignment, which is, the video for the assignment is on the 7th. But I can't watch the video on the 7th right now because I can't time travel and it's the 6th. So I'm trying to watch this video, but this video hasn't come out yet because I don't want to watch this video on the 8th, which is tomorrow. And I say tomorrow, even though today is Thursday, because I was supposed to wake up at midnight. So it's still Thursday. I'm trying to watch a video that won't come out until Friday while I'm at work. Because I don't want to watch the video that's going to come out tomorrow when I'm at work Saturday. But I'm still going to wind up having to watch this video Saturday, which means I'm going to have to do, which means it's Saturday. And I want to have done before Friday. I won't even be able to start it until Saturday. So what I'm going to do is go back to sleep. Because my body I have these rhythms that I'm trying to build. And I can force myself to stay awake for no reason. I can force myself to stay awake for the sake of being awake. But there's no reason to do that. I do have assignments that I need to work on, but I can't do the homework until I watch the videos so that I can know what they want me to do. So even though I have the time to do my assignment, if I do the work wrong, I have to do it again. So I need to watch this video so I can know everything that's expected of me for this week so that I can do the assignments. So the assignments are going to have to be done Saturday and Sunday. And then I'm going to have to work on the final on Monday. I think it's due. These are due tomorrow, but that's fine. Wait, they're due shit. Oh, these are not the actual apps. I'll just do this now. These are not actual apps. They have 0 weight. They're just for completion points. Make your idea look nice. These are the laps. These are due. The 11th, the 10th, the 10th, the 10th, the 13th, the 9th. The 10th, the 11th, and the 9th. So everything's due Sunday, Monday, Tuesday. So Friday, Saturday, and Sunday are gonna have to be crunch time days. I'm just gonna have to crunch it out. And there's really not a lot I can do. I'm pretty much just wasting my time. I'm trying to keep a schedule, but you can make a schedule, but your schedule doesn't have to make sense. And I'm behind and ahead at the same time, which is dangerous. This is the reason why people tend to get overconfident, which is why, even though I didn't want to get up, that's why I forced myself, like, get up, go do your homework. So I'm within my schedule. This assignment is already turned in. It's done. It could be better, but it's already turned in. So I'm already one assignment down. I've only got 2 more left for this week. But I have to go over, so I can maintain this grade, so I can maintain my 96.11. I have to maintain my 96.11, I have to keep my schedule. I have to stick to the plan. So unfortunately, this video this time was kind of a waste, but it's part of the process. So as always, my name is Juan. I'm giving my 2 cents, and I'm going back to sleep. Force myself to go back to sleep. Force yourself to wake up. Only to have to force yourself to go back to sleep. I'm super good at planning. I got everything done that was supposed to be started at my midnight, before midnight. More homework will be done tomorrow. I've got to go get Nessa. I'll help her, and then I'll come and I'll do my homework. As always, my name is Paul Armstrong. I'm giving you my Okay. Adulting is hard.